is implicit differentiation. It's been a while. What do we do first? Okay, and so I get y to the first times dy dx minus 3x squared equals 1. Everyone agree? Add the 3x squared over. This one was a relatively easy implicit differentiation because you didn't have a chain rule or a product rule. Today we're going to go backwards. We're going to learn how to go from this back up to this. So we're going to solve what's called a differential equation. Okay, so a differential equation is any equation involving a derivative. Dy dx equals 3x cubed plus 5. Y'all could probably go backwards on that pretty easy without much effort. dp dt equals k times p squared. That's a pretty important one we'll talk about later. Or they could get really nasty. As you already know, we often know the derivative and need to find the original function. Sometimes finding the original is easy. You just integrate. However, as you can expect, some differential equations are very difficult to solve. In fact, there are people in colleges, professors, who spend their entire research trying to solve one differential equation. Differential equations are really important in real-world applications in physics, chemistry, biology, economics, fluid dynamics, dozens of other fields. There is even a differential equation that is so important in oceanography that the Clay Institute will pay anyone who solves it $1 million. Obviously, it hasn't been solved yet. So there are some very difficult differential equations. However, fortunately for you, the only type of differential equation in Cal 1 is called a separable differential equation, and it turns out that it's quite easy to solve. So that's all that we're going to be working on. But I do want you to know that differential equations is a huge field. There's a whole class in college devoted to differential equations. Cal 1, 2, 3, the class after Cal 3 is called differential equations. And there's a class after that called partial differential equations. So it's a very large field, and it's very applicable. Most professors who do their research in differential equations pair with someone else. There was a professor at UCA who did his research in differential equations, and he paired with a biology professor, and they were modeling MRI brain imaging with differential equations. So it's not a field that's just mathematical. It's a field that's the math behind other things. Pretty cool stuff. So, how to do it? Step 1, you separate the variables. And I'm going to put only by multiplication. You can't add or subtract them to separate them, and I'll show you what I mean by that. It's mathematically, you should know that when we start looking at the equations, but some people try to mess that up. Integrate both sides. Don't forget the plus c. Find the plus c using the initial condition. If there's no initial condition, then skip that step and leave it as a plus c, and then solve for y. Yes, sorry. I can't. Okay, so we're going to look back at the bell ringer, and we're going to go backwards. one, you separate the variables. The first thing I would do is kind of cross multiply to get rid of the fractions. But essentially you're going to multiply and divide by the different pieces to get all the y's on one side and all the x's on one side. You have to have all the y's with the dy and all the x's with the dx. See what it means by separate the variables? You have to have all the y's with the dy and all the x's with the dx. Again, if this 1 had a y with it, I can't subtract it over. Does everyone know what I mean by that? In fact, if the 1 were a y instead of a 1, this would not be a separable differential equation. I couldn't solve it in Cal 1. You have to be able to multiply and divide by things to get the variables by themselves. That's what makes it a separable differential equation. If you can't do that, then it's not a Cal 1 problem. Step 2, integrate both sides. On the left, would you agree I get 1/2 y squared? On the right, I get x cubed plus x plus c. Now, a lot of people, which this next question is a good question, a lot of people want to put a plus c on both sides, which you could do. What does c stand for? Could you subtract them over and make just one constant? So, do we need a c on both sides? No, we can lump them together into one constant. It's not that we're not putting a plus c, it's just they're all the same, both constants in one c. Step 4, find c. How am I going to go about finding c? Plug in a point for x and y. The point was 1, -2, so I'm going to put -2 in for y and 1 in for x.
Then if you put plus c on the left side of the equal sign and then you subtract it over, wouldn't it cancel out the other one?
They're not the same c necessarily. I mean, maybe they are, but they would be two different constants, and so you could lump them in together and say I've got one constant. 4 divided by 2 is 2. 0 equals c. So sometimes c is 0, just like with regular integration. So I have 1/2 y squared equals, what was it, x cubed plus x. Last step is to solve for y. So I'm going to multiply by 2 and take the square root. Anytime you take a square root, you get a plus or minus. However, would you agree that's two different functions? There is only one solution to a specific differential equation through a point. Remember, I was going through the point 1, -2, correct? Which one would give me a -2, the plus or the minus, when I plug in 1 for x? The negative? Does everyone agree? So, the solution to the differential equation is a function and it is the one with a negative. This solution is what's called the specific solution to a differential equation. If we don't have an initial condition, we can't get this good. I'd have to leave it as a plus or minus, and there would be a c involved in the answer. Does everyone know what I mean by that? Those are called general solutions to differential equations. So a specific solution is one where you have an initial condition. A general solution is one where you don't. So we're going to do some more examples. Step 1. What do I do? Cross multiply or separate the variables in general. Did they separate well? Did they separate well? Yes. It was easy to get all the x's on one side and all the dy's on one side. Make sure you put dy on the top and dx on the top. Don't divide by dx or dy. We don't know how to integrate like that. Integrate both sides. What is the integral of just plain dy? So, step 1, 2, what's step 3? Find C. X is 1 when y is 4. Negative 1 3/4. Negative 7/4, is that right? I better check that math. Good. So y is 3/4 x to the 4th plus 5x minus 7/4. I don't have any decisions to make on plus or minus because there's not a plus or minus. Y is already by itself. I'm done. Could you check and see if you're right? Take a derivative. Do you get that? If you do, probably right. Oops. Okay. Solve dp dt equals kp if p of 0 is 20. I think that's what that says. Yeah. Notice the variable here is dt. What does that mean for k? K is a constant. It is not a variable. P and T are the variables in this equation. So K is just some random constant. I am going to separate the variables. That was an interesting D. But I am going to do something a little strange. I'm going to leave the K over here. Can anyone think of any reason I would do something crazy like that? It's just a constant. Would you agree it's easier to deal with a constant that's not a fraction than a constant that's a fraction? So just for simplicity's sake, I'm going to leave it over there with the t. I could put it anywhere I wanted to, so make your life easier. Integrate both sides. What is the integral of 1 over p dp? Very good. Well, taking your gateway exam. What about the right? Plus c. Plug in 0 for t and 20 for p. Yeah, my computer's struggling today. It just can't do calculus as fast as we can. So c is natural log of 20. Why did I get rid of the absolute values there? Yeah, right. 20 is 20. Now, if it were negative 20, I'd need the absolute values in there, but...
But what do you put? Oh, never mind, it's plus t. I was thinking you put in 0 for k.
Yes.
The p is 0 equals 20. How do you know which one's p and which one's k?
The dy is always on the top, right? dy dx or dy dt. So P is the y value, right? P of, this is like function notation, f of 0, which is the y value when time is 0 or when x is 0. Function notation is it's the same. We changed the letters, but so natural log the absolute value p equals kt plus natural log of 20. Oops. Okay. I want to get p by itself. How do you get rid of a natural log? E. Does everyone agree with that? And what does an absolute value do? Plus or minus, right? This thing could be positive or this thing could be negative, right? Everyone agree with that? So, if I'm getting positive 20, which one is it? Positive. If that had been negative 20, then it would be the negative exponential function. And one other step, it is not a requirement on open response, but on multiple choice it will happen. When you are adding two things in an exponent, isn't that the same as multiplying? Like that. This is just a constant, right? E to the c is just a constant. I'm going to call it C1. It's interesting. Any differential equation in the format a constant times the y value gives you PERT, the PERT formula.
The E to C,
Mm-hmm.
you know what C is? Do we put that in? Like,
I don't know what. Oh yeah, why didn't I do that? I don't know what I'm doing there. Thank you. Which really simplifies this because what's E of natural log of 20?
Do you want this?
20 E to the KT? Any questions about that? I'm glad y'all are paying attention. Okay, the next one is a tricky one. I want you to look at it for a second and see if you have any ideas. What's the kicker? What do we have to be able to do? We have to be able to separate x and y. I'm telling you that it can happen, but it's tricky.
Can you do a logarithm like a rule?
P to the X divided by E to the Y.
Or whatever. The natural log or whatever.
Say that louder.
E to the X divided by E to the Y.
Is this the same as e to the x divided by e to the y? Is it? So properties of exponents. So you were almost there, Grant, when you said logarithm, property of logarithms, but property of exponents will be easier. And now can I separate those variables? Grant, the big thing you missed is that the only way you can separate them is if you can multiply or divide.
So you're always going to be able to separate them.
In Cal 1, yes.
So what's like what are we trying to do? What's the main thing?
Solve the differential equation. So find out the function y that causes this to be its derivative. So quick. Oh, oops. And you'll probably want to watch the video for all the ins and outs, but this was back to the bell ringer, except we went backwards and found the function. So that's what we're doing. Like I said, there's some little kinks you'll want to go watch, like the little plus and minus thing we talked about, but essentially that's the game plan. what is the next step after you get the variables separated? Integrate both sides, because it gets rid of that differential. So I get e to the y equals e to the x plus c. Remember, I don't need a c on both sides, but I do have to have a c. X is 0 when y is 2. What's anything to the 0 power?
1.
So c is e squared minus 1. So I get e to the y equals e to the x plus e squared minus 1. Any questions so far? And last step. Good, I need y by itself. It does involve a natural log. I don't need an absolute value on that natural logarithm. I didn't get it by anti-differentiating. I got it by solving. And this is a positive number always. Would you agree with that? Because e squared is bigger than 1, and e to the x is positive, so that logarithm is fine. Again, I don't have a plus or minus to decide on here. If I did, I would make a decision and pick the appropriate plus or minus. Okay, we're going to talk about domain. We have time. Domain can be a little tricky when you're talking about differential equations. Go ahead and write down the steps, and then we'll do the problem, and I'll explain.
Are we on a different schedule?
Tornado. I knew that there was a possibility of a tornado drill. You never know if it.
Tornado?
No, of a tornado drill.
I just don't understand why we always do it at certain hours.
They're trying to make it where classes aren't messed up as much, which is nice. But you're right, it does kind of affect the authenticity of.
We only allowed to have a fire during the first hour.
Yes, I know.
It would be cool if the actual day that we did have fire wasn't first hour. Or right after first hour.
We hope that just never happens.
I mean,
You do know I'm videoing, right?
it was a joke.
I know.
I was kidding.
I'm aware.
I'm probably going to be the only one watching this later.
Probably. And Kelsey. Grant says he's sorry, Kelsey. Okay, so step 1, we're going to narrow down the domain to include only the x values that work for both the differential equation and the particular solution. We're only going to keep the part of the domain that fits the initial condition. So let's start by solving the differential equation. Step 1. What do I do first? Yep, separate the variables. I need all the y's with the y and all the x's with the x. So if I did just cross multiply, does that get me there on this one? No. What do I need to do? And you can skip this step. It's completely unnecessary. Most of you can do that instead. But what do I need to do to make this correct? Good. I need 1 over y dy equals 1 over x dx.
And this is only if the positive fractions.
It is. You have to have all the y's on the same side as the dy and all the x's on the same side as the dx.
So if it's like backwards like that,
Mhm.
we would use this.
But in general, you're always going to want y's with the dy, x's with the dx. However, you have to make that happen. But remember, you can only multiply and divide. Integrate both sides. Sometimes in this integration, you will need a U substitution or some integration technique. Don't shortcut just because it's a differential equation. If you need to do whatever you need to do to find the antiderivative, that's what you do. Find C. I always recommend you do it at this step. Of course, you could find C at any step along the way, but it will be easier before you solve for Y to go ahead and have all numbers. So that's why I have you do it at this step. But I do want you to know if you did it later, you wouldn't be wrong. Just more chance of messing up, in my opinion. Natural log of E equals natural log of 1. I did not just ignore the absolute values. Make sure if you don't write them, that you don't write them for a reason. But I didn't write them for a reason, correct? Because the natural log of E, E's positive. I don't need absolute values. What is the natural log of E? It's natural log of 1. So C is 1. So I have natural log of the absolute value of Y equals the natural log of the absolute value of X plus 1. What do I need to do now? E, so I get absolute value of Y equals E to the natural log absolute value of X plus 1. And we did learn a cool trick that I can separate that out to be E natural log of X times E to the 1. Does everyone agree with that? What happens to the E in the natural log? Cancel. So I get absolute value of Y equals E times the absolute value of X. Now I need to decide on plus or minus. I actually have two absolute values, but if I plug in 1 and get a positive E, what does that mean for whether this is the plus or the minus? Positive. So Y just equals E times X.
So what did you, so if it was negative, what would make it?
So if f of 1 equaled negative E, then I would want a negative in front here. Because if I plug in 1, the only way to get a negative E would be if that had a negative sign in front. The absolute value lets me know that it's either one or the other. Could be positive, could be negative. I want to talk about the domain of this. Okay. Just glancing at it, what's the domain? If I just look down here. Isn't that line? Negative infinity to infinity, right? But wait a minute. Isn't this part of the same stuff? Can X be just anything here? What can X not be up here? Does everyone agree with that? So the domain is negative infinity to 0, 0 to infinity. However, with differential equations, we made this choice of equation based on what side of the equals or the plus or minus, right? Would this equation necessarily work for being negative? In fact, no, it would need a negative sign, wouldn't it? So, the domain of the solution is only 0 to infinity. Not all the way negative infinity to 0, 0 to infinity. So let me go back up and read the steps again, and they'll make a little more sense now. Narrow down the domain to include only the x values that work for both the differential equation and the particular solution. That was how we got negative infinity to 0, 0 to infinity. Only keep part of the domain that fits the initial condition. You're only going to keep one open interval. So if there were multiple parts to the domain, only one of them is going to be in the answer. Essentially what we're doing is we've chosen our differential equation based on our initial condition. So the domain outside of that interval is not relevant. We'll talk more about that when we do a thing called slope fields in a couple days. But So, this is from a textbook. The domain of the solution, technically the domain of the particular solution of a differential equation, must be an open interval that contains the initial condition, and on which the differential equation is true. Practically, this means that the graph must go through the initial point and may not cross an asymptote or contain a point where it's not defined. So, this is just an example. Let's do another one. I think we might get one more in. State the domain. That's what I'll do. We have one. Okay, so we only have one more example. Probably one example we're not getting to today. Okay. Step 1. Multiply the square root of y, dy. The 2 could go anywhere. Does everyone agree with that? Could go over there with y, could go with the x. Make your life easy. Leave it as a whole number. Integrate both sides. How do you integrate y, the square root of y? Good. Brady, you still with me? Looks like you. Good so far? 0 in for x, 9 in for y. Again, we could solve for c at any time. The earlier you do it, the easier it is to me. How do you do a 3/2 power? This could be a non-calculated question. Square root of square root of 9. What's 3 cubed? 27. 27 divided by 3 is 9. 9 times 2 is 18. No. Wait. Maybe. Yes. Yes, you could have. 54 divided by 3 would be 18. You could not multiply the 2/3 in before you did the power. You have to do the power first.
So the top fraction, right there, the top there, you get divided by 2, or 9
Cubed. And then the square root. Which would be much more difficult than doing it the other way.
I just never thought of this.
Multiply by 3/2. Which is 3x 27. Is that right? And then raise both sides to the 2/3 power. That was taking a cube root. When I take a cube root of both sides, do I need a plus or minus? No. Is it worth noting whether I need a plus or minus or not? Yeah, if it's a square root, if that 2's on the bottom here, I would need a plus or minus. Domain of this. All real numbers, right? This one? Y can't be negative, agreed? Or 0. But domain's not y. So now I need to go back to this and go, okay, what would make y negative? Because y can't be negative or 0, right? Would you agree that 3x plus 27 has to be? The square actually takes care of the negatives. You agree? So this won't ever be negative. But it can't be 0. Agreed?
It can be -9.
Why not -9? Yeah. Because then I'd get 0. Y would be 0. Y can't be 0. Right? That was against the rules. Y can't be 0. So, what's the domain? Well, -infinity, -9, -9 to infinity. However, where was my initial condition? You have no idea what this weird thing is that I'm putting up here. But the domain is -9 to infinity. not negative infinity to negative 9, because 0, x being 0, was not on that interval. Try to get it done by Monday. If there are a couple you don't have answered, we won't grade it Monday. We will grade AP packet on Monday. The parts that you